Welcome back. Today we're going to be talking about fractional changes. Our content objective is students will be able to find the total price on discount problems with a fractional discount. Language objective is students will be able to state using complete sentences the answer to percent word problems. And why am I learning this? Well, it's important for many real-life problems like finding out how much money you're going to pay for an item. So remember, markup, tax, tip, and gratuity are all words that you would essentially be adding more to the amount. Now, words such as discount and percent off and markdown are all words that would reduce the original amount. And then the word that doesn't go to either marking something up or marking something down would be commission, which is essentially a percentage of an amount paid to a worker. So from 6th grade, hopefully you remember how to find the percentage of a number. So essentially you are multiplying. Now when you multiply, you need to make sure you turn your percent into a decimal. So just moving that decimal over 2 places to your left will do the trick, and you'd be able to multiply and you would be able to get an answer. So now what if it's a fractional part, maybe 1/5 of 40, for example? If we knew the percent, we could do this the same exact way. So what is 1/5 as a percent? Well, 1/5 is 2/10, which is 20%. So once you divide this, you would get 2/10, but then to turn it into a percent, you would just move the decimal over 2, and that's how we would end up with 20%. So in other words, this is essentially 20% of 40, which is 0.2 times 40, which would then be 8. So remember, converting fractions to decimals and decimals to percents. For fractions, you're essentially dividing numerator by denominator every single time. It's not always the larger number that goes inside. It's always numerator, aka the top of the fraction, divided by denominator, aka the bottom. So here, if you divide this out, you'll see that it's 0.5. So to turn into a percent, you're just going to move that decimal over 2 spots to your right, and that would have made it a 50%. So 1/2 is 5/10, which is then 50%. So let's try 2/5. To turn it into a decimal, you're going to do numerator, which is 2, divided by denominator, which is 5. So here, just bring your decimal straight up. And in this case, 5 would go into 24 times evenly. So now to turn it into a percent, just move the decimal again 2 places to your right, and that would make it 40%. So 2/5 is equivalent to 4/10, which is then equivalent to 40%. 3/8, same idea. You're going to divide to get a decimal. To turn into a percent, just move that decimal over 2 places, and then you would have a percent, in this case 37.5. So all of these are equivalent. They're just different ways of expressing it. One is a fraction, one's a decimal, one's a percent. So here it says, after a 1/5 discount, the price of Super 6 skateboard is $140. What was the price before the discount? So we're going to use our equation y equals kx. Y is representing the amount after the change, and then k, of course, is representing the percent after the change. And x is the original amount, so it's the amount before any of the change. So here, you can think of y as your new price or your new amount. K could be the percent after change, and then x could be the original price or amount. So now all we have to do is plug in the information that we can get. So here, for sure I know this $140 is what you will be paying at the very end after your discount. So we're going to place y with 140. Now here's a part that you have to be very careful about. I do understand that there is a 1/5 discount. Right now, let me go turn it into a decimal so I can see what that is. 1/5 is 1 divided by 5. Bring up the decimal, 5 goes into 10 2 times. So this is essentially 20%, which I'm just going to leave as 2/10. So here's the thing. After everything, after the discount, I paid $140. So what does that mean? that means if I get a discount of 20%, that means I am paying for 80%. And I can prove it to you. So with 100% of the item, if I'm getting a discount of 20%, that is me subtracting 20%. So how much did I actually pay for? I only paid for 80% of it, which if you move the decimal over is 0.8. So I'm going to go ahead and say 140 equals the 8/10. Now they are asking me for how much it originally cost before everything, and so I'm going to go ahead and leave it as an x. So all you would have to do now is solve for x. So I'm going to divide both sides by 8/10. And let me quickly do that for you off to the side. So I would go ahead and say that x equals $150, which to me makes sense because, of course, the price should be more expensive than what I was originally paying because I got a discount. Now, another way you could have done it is just using the fraction. If you are saving 1/5, that means you are paying for 4/5 of it. So you could have solved it this way. You would divide both sides by 4/5, and you still would, end up with $175. So either way would work. So a Super 6 skateboard costs $140 now, but its price will go up by 1/5. What will the new price be after the increase? Now here's where things are going to get tricky because you need to really be careful with what they're asking you, because depending on what they're asking you, these numbers will belong in different areas. So for this one, it says a Super 6 skateboard costs $140 now, but its price will go up by 1/5. What will the new price be after the increase? So in this case, they want to know what the new price is going to be. So y is going to remain a y. Okay. Now with that said, if it's getting marked up by 1/5, hopefully you remember this is 20%, which is basically 2/10 as well, however you want to see it. Okay. So that means if you're marking it up 1/5, that means you're paying for 100% of the item plus the 20%. So altogether, you're going to have a grand total of 120%. So now let's change it into a decimal. So it's going to be 1.2. So I'm going to go ahead and say y equals 1.2. And then I'm going to go ahead and say, well, how much did it originally cost? Well, it originally cost $140, so that's where it goes. So this one's nice because automatically once you multiply, you'll be able to find your new price. So we're just going to multiply, which is going to be $168. But wait, would there be a different way? Yes, you could have also thought of it as 6/5. How did we get 6/5? Well, because 1/5 plus a whole number, which we can say plus 5/5 if that helps, because that's a whole. 5 divided by 5 is 1, would give us 6/5. Now, do you think this would give us the same answer? The answer is yes. It would still be $168. So number 1, a music store is having a sale on a CD. The regular price of the CD is $15. The CD is on sale for 1/4 off. What is the discount? So here again, you have to be very careful. They're only interested in figuring out the discount. So we're going to go ahead and use our equation. But before we do that, let's go ahead and determine what 1/4 is. 1/4 is 2,500. Hopefully you understand that that's a quarter, right? We can also read this as a quarter. If not, you could have just simply divided it out and you would still get 2,500, which means that is 25%. So all we need to do is find 25% of $15, because once we do that, we'll be able to figure out what the discount is. So one way is to use a proportion, right? Is to put the percent, which is 25 over 100. This is your whole, because that's the original, so we're going to put that in for our denominator here. So you could definitely solve it using this proportion. Or you can set it in our equation and say, well, y is the new price, so y is going to equal the 25% of the $15. So this is only giving me the discount. So what would that be? It's going to be $3.75. Now another way to do it was to go ahead and keep it as a fraction. So you could have done y equals 1/4, which was the discount, and multiply it by 15, and that still would also give you $3.75. Number 2, a department store buys a sweater for $23. They mark it up 1/5 before selling it for a profit. What is the markup on the sweater? So here, they're only asking me to find the markup. They're not asking me to find a final price. So here, we need to be careful to only look for the markup. So first things first, let's go ahead and turn that 1/5 into a decimal. Hopefully you remember from previous ones that 1/5 is 20%. So it's 0.2 and 20%. So one way to do it is by setting up a proportion. The percent is 20, so we're going to put 20 here. And this $23 is the whole, so we're going to put that in our denominator. Let's put a variable here, and you can go ahead and solve that proportion if you like that way. Or you can use an equation, y equals kx. Y is the new price. We don't know the new price, so we're just going to leave it as y. But we know k is the percent, which we're going to go ahead and call 0.2. And we're going to take the 20% of the $23. So 0.2 times 23. When I multiply this out, I will get that y equals $4.60. So how much is the department store marking up this sweater up by? They're going to make it $4.60 more expensive. Now, once again, another way to do it would to have been leaving the fraction as a fraction, of course, and still multiplying it out. You still would get the same exact answer. Number 3, Jennifer's dinner comes out to be $47. She wants to leave a tip that's 3/20 of the bill. What is the total amount she is spending? Ooh, this one's a good problem. This one's different than the rest because they're asking us to figure out what is the total amount that she's spending. So they're not interested in just the tip alone. They want to know everything including the tip. First, let's go ahead and turn 3/20 into a percent. We're going to do 3 divided by 20. That means this is equivalent to 15%. So since Jennifer is wanting to figure out how much she spent all together, we're going to have to do 100% of the bill, but we're going to add on 15% for the tip. So she's going to pay a total of 115% of her grand total of $47. So let's go ahead and do that. Let's set it up as a proportion. And the proportion is going to be, the percent is 1.25. Hopefully you can see moving the decimal 2 spots. That's where it would be. So 115 is our numerator. 47 is the original price, so that's going to be our denominator for the whole. And now just put a variable and solve. So that's one way of doing it, or you can set it up as an equation. So here, $47 is X. It's the original price. But we're going to go ahead and do 150% of that. So it's going to be y equals 1.15 times 47. Now if you multiply that, you're going to get $54.05. So you need to understand this value right here doesn't represent how much she's going to tip. This represents how much she's going to tip including her bill of $47. So that's important to understand. Now, of course, there was another way. You could have also used it as a fraction still. Now, one way to do that is think of it as 3/20. Of course, you're going to include that as a tip, but you have to include the whole price of the item. So you would add one whole. I could put a 1, or to make things more simple, I can just go ahead and put 20 over 20. Why? Because 20 over 20 is also 1. So that's going to be 23/20. If you multiply those out, it still gives you $54.05. So at the end of the night, Jennifer will pay $54.05 because that's including the $47 she spent on food with a 3/20 tip. For number 4, it says after discount of 7/20, the price of a computer is $325. What was the price before the discount? So first we're going to turn 7/20 into a decimal, which is 3500ths. So we're going to go ahead and convert that into a percent, which is 35%. So here, what you need to be careful about is if there was a discount of 7/20, which is aka 35%, that means we need to figure out how much was actually spent. What percentage did we spend? So we're going to have to do 100 minus 35%, which is 65%. So yes, the discount was 7/20, which is 35%, but we're talking about how much we ended up paying. So in that case, how much did you pay? You only paid for 65% of it. So since they want to know the price before the discount, we're going to go ahead and plug in our value. So first, as a proportion, we would put 65% or 65 over 100. We're going to put 325 as the part. Because notice 325 is no longer the original. 325 is the new value after the discount. So that's where you have to be very careful. It's no longer the denominator anymore. Now, the other way would be to use your equation, y equals kx. This one's a little bit straightforward. You need to know that this is your new price, so that's going to go in for y. 65% goes in for x, and since I'm trying to figure out the original price, we're going to go ahead and leave an x there. So you just have to divide both sides by the 6500ths, and you're going to end up with x is 500. So what does this mean? It means this computer originally cost $500. A clothing store is having a sale on a shirt. The regular price of the shirt is $36 and is on sale for 3/4 off. What is the sale price on that shirt? So first you need to understand what 3/4 is. Hopefully you can also understand this could be read as 3/4. How much is 3/4? Well, you can think of it as 75 cents, which just so happens to be our percent as well. Now you could have also divided it, you still would have gotten the same value. So they were getting a 75% discount. So if they want to know the sale price, if you are saving 75%, that means you're spending 25%. I can prove it to you. Here's 100% of the item. If you're getting a discount, you're going to subtract that 75%, which leaves us with 25%. So now we're going to go ahead and set up our proportion. That's going to be a 25 over 100. And here, this 36, is it an original amount or is it a new? Well, it says the regular price on the shirt is $36. So we're going to go ahead and put it as our denominator, and n would be our numerator. So that's one way to solve it. Or you can go ahead and use your equation, y equals kx, where y, we don't know the new price, which is your sale price on the shirt, so we're going to leave y. But we know k is going to be 2500ths, which is 0.25, times, of course, the original, which was 36. Now, if you multiply that, you're going to get $9. That means that shirt only costs $9, which is pretty good. Now, you can also have left everything using the fraction, and you still would have gotten 9 as well. Number 6, it costs a hobby store $12 to buy a model plane. The store marks up the model by 2/5. Find the selling price of the model after markup. So here they want to know the selling price. So first things first, we're going to turn 2/5 into a decimal, which we can see here is 40%, which is equivalent to 0.4. Okay, so now going back to the drawing board, they want to know the selling price of the model after the markup. So they're not interested in just the markup, they want to know how much it is including markup. So of course you're going to have to include the 100% with the 40%, which is going to give us a grand total of 140%, which is equivalent to 1.4. So that's what we're going to do. 100 plus 40 is 140. So plugging that into our proportion, you would have 140 over 100 equals now 12. Is that the original or is that the new? 12 is your original, so that goes in the denominator, so you can solve this proportion. Or you can go ahead and just use the equation y equals kx. We don't know the new value with the markup. That's what they're asking us to solve. So we don't know y. However, we know k is 1.4. And again, just moving that decimal over. And it's going to, we're essentially taking 140% of the $12. So we're going to multiply that by 12. When you multiply that, you do get $16.80, but once again, you do have the option of leaving everything as a fraction. Here, what you would have to do is you would do 100%. Now, since we are using 2/5 on this end, I think it would be a good idea to use 5/5. Why am I doing this? Because 5 over 5 is 1, and that helps me out. So that would be 7/5. So you could have taken 7/5 of 12, and that would also have given you $16.80. So, how much is this model plane going to cost after the markup? It will cost $16.80. Number 7, the original price of an item is $52. The item is on sale at a discount of 1/5 off the original price. You then have to pay a sales tax of 8%. What is the amount you paid for the item? Ooh, this is a good problem. So the first thing we want to do is use our equation y equals kx. If you're receiving a discount of 1/5, which, if you remember, is going to be 20%, then that means you're only paying for 80% of the price. So we're going to go ahead and take 80% of 52. But then on top of that, you're paying an 8% tax. So we're going to do 1.08. Why are we doing 1.08? Well, first of all, 8% written as a decimal would be 0.08. So why did I put a 1 in front? Well, with this 8%, you have to include 100% of whatever you were buying. So 8 plus 100 became 108. So if you move the decimal over, that's how we ended up with 1.08. Now if you multiply these all together, you are going to get $44, well, 44.928. Now with money, it doesn't make sense for you to go all the way to the thousands place. So what do? You round to nearest hundredth. This 8 will make this value go up, so I would say it's going to cost you $44.93. Number 8. After a series of price changes, an item finally costs $38.72. The change included a 10% markup and a 1/5 discount, and then a 10% fee. Find the original price of the item. This one's definitely a more challenging problem. So what do we do here? Well, we have to go step by step. The one thing that I do know is that the final cost is $38.72. So if I were to set up an equation in the form of y equals kx, that's definitely going to be my y value. So now I need to do things step by step. If the change included a 10% markup, markups make things more expensive, so I'm going to do 100 plus 10%, which is going to be 110%. So I'm going to take 110% of some value that I don't know yet, so I'm going to call it x. So it's going to be 110% of x. And 110% expressed as a decimal would be 1.10. But more happened to it. Then there was a 1/5 discount. Well, if it's a 1/5 discount, that means how much were you spending? Well, 1/5, if you remember from previous examples, is 20%, which means if you are saving 20%, that means you are paying 80%. So we're going to multiply that whole thing by 8%, which is 0.80. Now, we're not done. There was one more thing. Then there was a 10% fee. For fees, fees are typically make things more expensive. So what does that mean? That means we're going to do a 100% of whatever it was that they're spending plus a 10%. So 100% plus 10% would be 110. Turn that into a decimal would be 1.10. So how do I do this? Well, essentially what I'm doing is multiplying these three values together. I'll do it quickly for you. That ends up being 0.968. And then, of course, we have x. So to solve for x, you would just have to divide both sides by 0.986, and you would get 40. So that means it originally cost $40. The $40 with a 10% markup, with a 1/5% discount, and then with a 10% fee. So that's going to conclude the lesson for today. Thank you so much for tuning in. And as always, until next time, bye.